In this video, I will explain how to use method of undetermined coefficients to solve a differential equation. If you have a general form of differential equation, you will have a solution in the form of y equals y of c plus p y of p. Y of c is the general solution, which is, we covered last video, which depends on your roots. So you put your equation, have g equals 0, solve for your roots. If your roots are distinct, you get that form. If they're repeated, you get that form. If they're complex, you get that form. Though that would determine what your y of c is. It's your general solution. But for your y of p, your particular solution is which also has capital Y of t, is based off of your g of t. If your g of t is either the exponential, polynomial, or sine cosine form, that will dictate what form your particular solution is. If you have an exponential in form of e to the power of kt, you would get the yp ae to the power of kt. For example, if you have e to the power of negative t, you get ae to the power of negative t. If your g of t is a polynomial, your yp will be general form of polynomial, which will be, for example, if you have t to the power squared, you have at squared plus bt plus c. Now, if your g is a sine or cosine, then your yp will be the combination of them. For example, if you have sine of t, your particular solution will be a sine of t plus b cosine of t. Now, once you found your particular solution, your yt, you will have unknown coefficients in it, like a, b, c. So in order to solve for those, you will take your particular solution and find the derivative and second derivative of it. Once you have those two equations, you'll plug them back into the general form and solve for those coefficients. If you pick the right form for a particular solution, it should all work out. You should find your coefficients. Once you found those coefficients, you plug it back into your particular solution, so you have full particular solution with no unknown variables besides t. Should be. And then you take that particular solution, take your general solution, combine the two. You just add them together. And like it up there on the solution, y equals yc plus yp. So it should look something like c1 y1 of t plus c2 y2 of t plus capital Y of t. Should be like what your solution is. So now to show this process, let's do an example. This example is y double prime plus 3, minus 3y prime minus 4y equals 3e to the power of 2t. To solve, first, like we did previously, first you want to find your roots so you can find your general solution. Do the roots, find the negative 1 and 4. That will mean they're distinct. It's this form of general equation or general solution. You just fill in. Then to find a particular solution, your g of t is 3e to the power of 2t. Now it's exponential, so use that form. So your yt is ae to the power of negative t. So you take, it's not a negative t, I wrote that wrong. Oh no, it just didn't show. It's ae to the power 2t is what your solution is. Oh yeah, particular solution. So then your y prime of t equals 2ae to the power 2t. Then your y double prime of t is 4ae to the power 2t. So now you have all your derivatives. Plug it back in the original equation. Will look like this. Solve for a. Get a equals negative 1/2. Plug that back in. So particular solution in its entirety is negative 1 over 2 e to the power 2t. Plug that in with your general solution. You get that. That would be your solution. Now, what will happen if you have multiple of these in one g? Like if you have both an exponential and a sine and cosine. what you would do then is you would try and have to merge the two different particle solutions. You try and merge the AE power KT in the combination form. Like in the next example, it's the same y double prime minus 3, y prime minus 4y, so the roots in general solution will be all the same. But for our g, we got negative 8 times e2t cosine of 2t. In order to solve that, we will then have to, so we will combine the two. So instead of just being a cosine of 2t, it's a e to power t cosine 2t plus b e to power t sine of 2t. We derive that twice, get that, plug that in equation, get this really long thing, and you do the algebra to solve for a and b. You got those two, plug them back into the equation, you get particular solution of 10 over 13 e to power t cosine 2t plus 2 over 13 e to power t sine of 2t. Plug that in, that will be your entire solution. So that's what you do if you have two of these same particular solution forms. You merge them in one way or another. Like if you have an exponential and polynomial, it'll be at squared plus bt plus c times e to power t, or kt, for example, with that. And that's how you use the method of undeterminate coefficients.